Hello students, this is 9.9 Ideal Gas Law. So what I want you to do is pause this video and try this do not question. This question is involving your combined gas law. So remember the combined gas law, the formula for that is P1 V1 over T1 equals P2 V2 over T2. So go ahead and read the problem and please pause the video. So with this problem, it tells you that your temperature is becoming constant. So what you can do is you can either put 273 Kelvin for each of your temperatures, or you can just take that completely out. It doesn't really matter. But you should have set up your problem like this, where you have 100 kilopascals multiplied by 12.8, and then divided by whatever you said that your temperature is going to be. Right, so 100 times 12.8, that gives you, divided by 273, that gives you something that looks like this, 0.688. Right, you want to multiply 273 on both sides, and that crosses that out, and then divide by 0.9. You should have got your P2 that equals to 1,422 kPa, kilopascals. Alright, so let's kind of relate the combined gas law to the ideal gas law. So the combined gas law, it talks about how you have initial pressure and then you have a final pressure, initial volume and then a final volume, initial temperature and then a final temperature. The ideal gas, what it does, it relates all of these things as one complete unit. So we're relating pressure, volume, temperature, and then the new thing is amount of gas, which is going to be moles, all together in a given formula. The given formula for the ideal gas law is PV equals nRT. And if you look at your formula sheet, you know that the P is your pressure, the V is your volume, your N is your moles, the R is the rate constant, which we said was 0.0821, and your temperature, which is going to be in Kelvin. Alright, so if you read this problem, it says you have 4 moles of a gas at a pressure of 5.68 kilopascals and a volume of 12 liters. What is the temperature? The key thing here in the ideal gas law is because of your rate constant, which has units of 0.0821 atm liter for every mole Kelvin, your pressure has to be in atm. Your temperature has to be in Kelvin. And your volume has to be in liters. Every time you plug this information into the formula, you have to have proper units. So if anything is not in atm, you want to convert that. If your volume is not in liters, you do want to convert that, and you always want your temperature to be in Kelvin. So once you understand that, you can kind of plug things into the formula. So it says you have 4 moles of a gas, and it's giving you a pressure, which is in kilopascals, so you want to convert that. So for every 1 atm, you have 101.3 kilopascals. And then when you convert that, 5.67 divided by 101.3, you get 0.056 atm. So you can go ahead and plug that in now into here. Alright, it gives you a volume in liters, which is great. Alright, your rate constant is 0.0821 atm liters mole Kelvin, and we want to figure out what our temperature is going to be. So you can actually solve for this equation where you have 0.056, you multiply that with 12, and you get 0.672, and that's going to equal 4 times your rate constant, which is 0.3284 T. And then you're going to divide everything over. 2 divided by 0.3284, you get a temperature which equals 2 degrees Kelvin. right? Perfect. So your second example, it tells you that if I have 21 moles of a gas held at a pressure of 28 atms and a temperature of 20 degrees Kelvin, what would the volume of the gas be? All right, so you can plug in the information that's given to you in the problem. You have 21 moles. You know your rate constant is always going to be the same number. You have your temperature in Celsius. You want to convert that to Kelvin, and that's going to be 293. And then you are looking for volume, and it's giving you pressure of 28. So you kind of just want to solve for this problem, 0.0821 times 293, and divide over that. You get a volume of 18 liters. Alright, so for this problem, I do want you to pause the video, read it, and try to solve it by yourself, and then come back to it. So while reading this problem, it says you have a 10-liter gas canister that contains 10 grams of Xe xenon F4. So if you have 10 grams of something, in order to plug this into the formula, you have to change it to moles. So what you're going to do is you're going to look on the periodic table and find the molar mass of this entire thing. And when you do that, you get a molar mass somewhere equivalent to 207.282, which is ultimately going to result in this many amount of moles. Once you have your answer in moles, you can then go ahead and plug it into the formula. Remember, your rate constant is always the same. And then your temperature is what you're going to solve for. And it gives you your pressure in PSI. So you do want to convert that over. So you have 10,000 PSI. And you know that for every 14.7 PSI, that is equivalent to 1 ATM. Alright, so 10,000 divided by 14.7, you get your pressure as 680 ATM. Once you have everything in proper units, you can actually solve this equation and solve for your temperature, and you get a temperature that is going to be this many degrees Kelvin. Alright, so the problem is it's asking you what the temperature is going to be in Celsius. So once you have your answer in Kelvin, all you need to do is minus 273 in order to change your answer to Celsius. And you'll get an answer that looks like this huge number. So the last problem is the ultimate ideal gas problem. It's the same formula, same rate constant, same everything. So you have a deep underground cavern that contains 2.24 times 10 to the 6 liters of methane gas, which is CH4. And the pressure is in 1500 kilopascals with a temperature of 42 degrees Celsius. You want to figure out how many pounds of CH4 does the cavern contain. So go ahead and pause the video, convert everything into the proper units, and plug it into the formula, and then come back and see if you have the correct answer. So you want to start this problem by first changing your kilopascals to ATM. Alright, we know that 101.3 kilopascals is for 1 ATM. So when you do this, your ATM, you're going to get 14.807, somewhere around there. Your volume is already given in liters, so you can actually just go ahead and plug that in. You don't know how many N's you have, which is how many moles you have, but you do know what your rate constant is going to be. And when you convert your degrees Celsius to Kelvin, you get 315. Alright, so ultimately what you're solving for is your number of moles. So when you solve for your N, you're going to get your number of moles as this gigantic number. Right? This many moles of CH4. So what you want to do now is you want to convert this number of moles to ultimately pounds. So what you can do is you can use the molar mass of CH4, and say that for every 1 mole of CH4, you actually have 16.043 grams of CH4. Then you want to use the conversion factor. For every 454 grams, you have 1 pound. When you do this entire equation and multiply everything over, you're going to get a final huge number of 45,320 pounds of CH4. All right, 4. Perfect.